I'm part of IBM's Spectrum Enablement team. I support Spectrum Protect, previously known as Tivoli Storage Manager. I want to talk today about Spectrum Protect performance and specifically finding performance bottlenecks. I want to show you a tool built into the product that can help you find performance bottlenecks. We all know that IT environments are complex with multiple platforms, applications, database servers, etc., and many backup methods. Today, let's focus on a file-level backup and a simple way to detect what section of the backup path is taking the most time. This diagram of a simplified backup environment shows two clients, production servers, using a LAN-free data path to a disk storage pool. And here's a list of potential bottlenecks within our simplified environment. It's a pretty long list. Client disk, poor configuration, large workload, heavily loaded or under-resourced processor and/or memory, and that's just on the client side. Many times the network is the source of slowness. In fact, you should already know what your real throughput on the network is. I'll cover some ways to do that in another video. And let's not forget that the backup server environment has many components, and any one of them can cause slowness in the backup system. So when you have a performance problem, where do you start? Let's say you've checked the operations center and you see that one of your critical production servers isn't finishing its daily backup. So you click on the applications icon, and we see here that the Pilsner client is at risk. And when you drill down further, you find that it hasn't completed its daily backup in several days. Here's our simulated production system running a normal daily backup. However, we know that things aren't going well, so I'll show it like this. The red lines represent a bottleneck somewhere in the data path of Pilsner's backup. Is it the client disk? The database application? Something in the SAN? Maybe the Protect server? How do you know? Where do you start? We could start by looking at the operating system on the client or server, or we could start with the network, running IOStat or Wireshark maybe. But let's save that for another day. Let's let the Protect client tell us what it knows. And we're going to do that with something called client instrumentation. Instrumentation reports identify the time spent performing certain activities, things like querying the server, reading data, or sending data. Instrumentation is easy to use and enabled with an option called test flag in the client option file or place on the command line as seen here. We're going to instrument a BA client backup, so we'll use the instrumentation :detail argument. And again, there are two methods. Placing the option on the command line as a parameter to the backup command DSMC, or putting it in the option file. The difference is that when placed in the option file, anytime that client does a backup or a restore, a report will be generated. And this report will be written to a file in the directory specified by the DSM_log environmental variable and named dsm-inster.report.pnnn, where NNNN is the process ID of the backup process. If this environmental variable is not defined, the report will be written to the directory from where the DSMC command was issued. Please note that client instrumentation works only on command line or scheduled backups, not from the GUI or the web client. API and VE clients can also be instrumented, but you would use the argument API/detail instead of instrument::detail. If you choose to add this option to the option file, and you're using the sched mode of client polling, the scheduler will need to be restarted after saving the option file. Once enabled, a report will be written when the backup or restore completes. This report contains three major sections: threads, options, and summary. Within the threads section, there are two thread types: producer threads, which compare objects already backed up on the server to find any change files or directories, and consumer threads, which send or restore files and directories to or from the Protect server. Threads with categories query server DIRs, query server files, and process DIRs are producer threads. Threads that have file IO, data verb categories are consumer threads. Don't worry about the thread type names, they're really not important. However, what is important are the categories shown in the section column here. The two columns under the actual, average, and the number of occurrences of each category object under frequency used. Here's an example. One of the most important categories is data verb. This represents the specific category where data is sent to the server during the backup or received from the server during a restore. By the way, instrumentation also works with archive and retrieve, but for the sake of brevity, I'm just using the terms backup and restore. We can see here that this data verb took 27,000 seconds. And we're looking at data verb because it clearly had the most amount of time charged to it. And when we compare it to the elapsed time, you may want to get a calculator here, we see that this data verb represents 71% of the elapsed time that the thread was alive. Keep that in mind. That's an important part. Also note that all those data verbs for this thread average 4.3 milliseconds. There were 6.2 million of them. All good information that we'll see again later. Here's a list of important instrumentation categories and their definitions. Ones marked red are the most common bottlenecks. I suggest that you pause the video here and read through each one. You can find these documented in the TSM Optimization Guide, which is part of the online documentation. I'll put a link to that at the end of this video. The next section of the report documents all client options that were in effect during the backup. Initially, these should be set to the product defaults, unless a support person has suggested to change one. Finally, the summary data. This is what you also see at the end of every backup or restore. It may look a little different in the GUI, but it's there too. You can also see it in the dsmsked.log file that's appended to every day. The first thing that I look at here is total number of bytes transferred. If this is too small, the report won't be meaningful. Next, look at the aggregate data transfer rate and the network data transfer. On a healthy client, these two numbers should be fairly close to each other, as they are here. Now ask yourself, is this aggregate a good rate? Well, wait. What should it be compared to? It should be compared to your network throughput, but not the network data transfer rate you see just above the aggregate, the real network throughput on your system. And you should know that, remember? A good rule of thumb is a backup throughput of 60 to 80% of your network throughput. Not the network bandwidth, but the real throughput. Of course, like vehicle mileage rates, this too will vary based on many different variables. On we go. Let's look at a test backup. I'm going to run a backup of a Windows client. I'll back up the C drive incrementally. I'll type the backup command, dsmc space I space C : for the domain I want to back up, and then dash test flag equals instrument : detail. We see the backup starting, connecting to the server, processing files. Eventually, files flow to the server. I'll jump the video ahead to save time. Now we see that the backup has completed. Here's the report located in the BA client directory. The top two lines of text let us know that we are indeed at the top of the report. Next, we see the timestamp, type of instrumentation, and status. Then we see two threads, 7200 and 8264. The second thread is the producer thread, the one that is responsible for figuring out what to back up. I know this because I see query server DIRs and query server files at the top. Remember? Only producer threads have these categories. Thread 7200 is the consumer thread, but let's save analysis for these threads for the last. The next section shows us the actual backup command, and then all of the options and their settings that were in effect during the backup. The final section shows the server version and the connections during the backup. Let's continue with our analysis. As I mentioned earlier, let's look at the amount of data sent to the server, 410 megabytes. Not a huge amount, but this was a test of a bunch of small files. Next, network data transfer rate was 1433 kilobytes per second, and the aggregate was 70 kilobytes a second. That's a big difference, and since the network rate was much larger, it appears that the network isn't a bottleneck. Let's go back up to the two thread stanzas and see what they tell us. When I look at the producer, 8264, I can see that it spent most of its time in thread wait. Since it wasn't doing much work, mostly waiting, we'll ignore it. It's not the bottleneck. So what does 7200 tell us? How long was it alive? 599 seconds. If you remember, that was also the total elapsed time. What category has the most time charged to it? File I/O. And when I look at the average for each I/O, it's 111 milliseconds. That's very slow. It should be in the range of 1 to 5 milliseconds for enterprise disk. There's the bottleneck. And since we found the bottleneck on the client side, we're done. No network or server investigation. The next step would be to find out why the disk is slow, resolve that, and run another test backup. Of course, there will always be a bottleneck. The question is that bottleneck acceptable in terms of getting your daily work completed? I hope this video clearly demonstrated how to use the client instrumentation and that you enjoyed learning about Spectrum Protect performance.